Hello and welcome everyone. I am Himanshu Mishra in front of you with the topic simple harmonic motion. So let's start our session. See, in our previous session, we have discussed about the term velocity, acceleration, as well as displacement and restoring force. Now we are going to discuss these terms in the maximum form. Also, we will compare these three terms as well. So let's start. First of all, what is the general equation of displacement? So if we take initial phase as 0, so displacement equation can be written as y is equals to a sine omega t. Now tell me what will be the velocity. So velocity can be expressed as v is equals to a omega cos omega t. Now tell me what is the extreme value of sine theta and cos theta. So the extreme value of sine theta is plus minus 1, whereas the extreme value of cos theta is plus minus 1. These are the maximum values. So what will be the maximum velocity? So maximum velocity can be expressed as V max is equals to plus minus a omega. See, I have taken the both the signs plus and minus. So what is the plus? If the object is moving in forward direction, we will take the velocity as positive, and if object is moving in backward direction, we will take the negative sign. So V max is equals to plus minus a omega. Now what is the acceleration? So what is the acceleration? Acceleration a is equals to dv by dt, and if we will differentiate it, it will become minus a omega square sine omega t. So this will be the acceleration minus a omega square sine omega t. Now tell me what is the maximum value or the extreme value of acceleration. So maximum acceleration can be written as a max is equals to plus minus a omega square. So these are the maximum terms. Now what is the maximum restoring force? So the maximum value of restoring force can be written as F is equals to m into a max. So F is equals to plus minus m into a into omega square. So this is the maximum value of restoring force. Now we are going to compare these terms. So we'll make a table. Now the serial number 1 is displacement. So the displacement can be written as y is equals to a sine omega t in terms of t. And if we write in terms of displacement, so y is equals to y. And what is the maximum displacement? So we all know what is the maximum displacement. Y max can be written as plus minus a amplitude. Amplitude is betterly known as the maximum displacement. So y max is equals to plus minus a. Now tell me how the graph of displacement can be drawn. So the graph of displacement can be drawn. This is y and this is t. So this is a equation of sine, so this will be a sine wave like this, and these are the extreme values. So these are the extreme values. What is the extreme value? Extreme value is plus a, and this is the minus a. So this is the graph of displacement. I hope this is good for you. Now, what is the second term? Second term is velocity. What is the general equation of velocity? So v can be written as a omega cos omega t, and if we rewrite in terms of displacement, so v can be written as omega under root of a square minus y square. We have discussed this expression in our previous session. We can go through that video as well. So what is the maximum velocity? V max can be written as plus minus a into omega. Now the graph of velocity can be drawn as, so if we are going to draw the graph, this is time t, and the curve of velocity is cos, so the graph will start like this, and the graph will look like this. What is the maximum value? Maximum value is a omega, and extreme value minus a omega. So the graph of velocity will look like this. Now we are going to draw the third term, or the term of acceleration. Acceleration. So acceleration can be written as a is equals to minus a omega square sine omega t. This is the expression in terms of time t, and in terms of velocity, so in terms of displacement, a can be written as a is equals to minus omega square into y. And what is the maximum acceleration? A max can be written as plus minus a omega square. Now, can you draw the graph of acceleration here? So let us try to draw the graph. This is time axis, this is acceleration a, this was velocity v. Now, can you draw the graph here? See, the acceleration equation is minus sine curve, so the graph will look like, कहाँ जा रहे हो भाई साहब? The graph will look like this, and the magnitude or the maximum values, so the maximum values are minus a omega square and plus a omega square. So this is the comparison between displacement, velocity, and acceleration. See, we will discuss this further as well. Now I am going to draw the graph again so that we can discuss further. See, this is the graph of displacement and time, and which was a sine curve. Now, what is the graph of velocity? So this is the velocity time curve, and the graph was looking like this. This is velocity time graph, and now we are going to draw the acceleration time graph. So the acceleration time graph is minus sine curve. Now, how will you compare this? See, अगर हम लोग इसमें ठीक तरीके से देखें तो द ग्राफ ऑफ वेलोसिटी विल स्टार्ट फ्रॉम this position. This is the position. So the velocity graph is ahead of y by pi by 2. So we can draw a conclusion, and the conclusion is that in S.H.M, so in simple harmonic motion, the velocity of particle leads displacement leads displacement by pi by 2, or we can say the velocity is ahead of displacement by pi by 2. Now what can be the second conclusion? So if we try to draw the acceleration time graph in this, so acceleration time graph can be drawn from here, and this will go further like this. So can we say that the acceleration is ahead of displacement? See, acceleration is ahead of displacement by pi, and this is ahead of velocity by pi by 2. So we can conclude two more things, that in simple harmonic motion the acceleration the acceleration of particle leads velocity by pi by 2. We can conclude one more thing from this, that in simple harmonic motion the acceleration leads the displacement by pi. So these three statements can be explained in one more time by that the displacement is behind velocity by pi by 2 radian, whereas the acceleration is ahead of velocity by pi by 2. So we can say the velocity is behind acceleration by pi by 2, whereas we can say the displacement is behind to acceleration by pi radians. So these are the basic major conclusions. Now we are going to discuss a question. A body executing S.H.M has maximum acceleration equals to 24 meter per second square, and maximum velocity equals to 16 meter per second, and the examiner have asked the amplitude of S.H.M. Now can we tell that the maximum acceleration A max can be written as A omega square, and which is equals to 24 meter per second square, whereas V max can be drawn as A omega, and which is equals to 16 meter per second. So can we calculate the omega? So if we divide 1 by 2, so 1 by 2, A omega square upon A omega is equals to 24 by 16. If we cancel this term by 8, so this term will become 3 by 2, and A will be cancelled out and omega will cancel the square term. So from this we can calculate omega is equals to 3 by 2 radian per second. Now substitute the value of omega in equation number 2. So from equation 2, a omega is equals to 16. Substitute the value of omega here. So a into 3 by 2 is equals to 16. So the value of a will become 16 into 2 divided by 3, which is equals to 32 by 3 meters, and the option A is correct. Now, what is the question number 2? What is the maximum acceleration of particle doing the S.H.M by y is equals to 2 sine pi by 2 into t plus pi, where 2 is in centimeter. So in this question, examiner have asked the maximum acceleration. So a max can be written as a omega square. Now we are going to find the value of a and omega. So from this equation we can compare with y is equals to a sine omega t plus phi, and by comparing we can conclude that the value of a is 2 centimeter, and the value of omega is pi by 2. So we can substitute the value here. So a max can be solved as 2 into pi by 2 whole square. So this will become 2 into pi square by 4, and 2 will cancel out 4 by 2. So the answer will become pi square by 2 a max, and this is the unit will become centimeter per second square. So the option B will be correct. So option B is pi square by 2 centimeter per second square. Now the question number 3, a particle executes harmonic motion with an angular velocity and maximum acceleration as 3.5 radian per second and 7.5 meter per second square respectively. The amplitude of oscillation is. See, in this question, the value of angular velocity omega is written as omega is equals to 3.5 radian per second, and maximum acceleration a max is given as 7.5 meter per second square. So substitute the value in a max. So a max can be written as a into omega square, and the examiner have asked us the amplitude. So a can be written as a max divided by omega square. Now substitute the values. A is equals to a max. A max is 7.5 upon 3.5 का square, and the answer will become a is equals to 0.61 meters. So the option D will be correct. Now the question number 4, a particle is executing S.H.M given by x is equals to a sine pi into t plus phi. The initial displacement of particle is 1 centimeter and its initial velocity is pi centimeter per second. Find the amplitude and initial phase of particle. See, what is the displacement equation? X is equals to a sine pi into t plus phi. Now the initial displacement of particle is 1 centimeter. So at time t is equals to 0, x is equals to 1 centimeter. Substitute this. So 1 is equals to a sine pi into 0 plus phi. So this term will become 1 is equals to a sine phi. This is equation number 1. Now there is one more condition given. The initial velocity is pi centimeter per second square. So at time t is equals to 0, v is equals to pi centimeter per second. But we all know the velocity. So the term velocity v can be written as dx upon dt, and this will become a into pi into cos pi by t plus phi. So in this equation v can be written as pi. So pi is equals to a into pi into cos pi into 0 plus phi. So pi will cancel this, and this will become 1 is equals to a cos phi. This is equation number 2. Now we will divide 1 by 2. So a sin phi divide by a cos phi, which is equals to 1 upon 1, and this will cancelled out. So this will become tan phi. So tan phi is equals to 1. So the value of tan theta is 1 at angle of 45 degrees. So phi is equals to pi by 4 radian. See, there are two options, option A and option B. Now we have to solve the amplitude. So substitute the value of phi in equation 1. So from equation 1, 1 is equals to a into sine pi by 4. So the value of sine pi by 4 is 1 by root 2. So a 1 is equals to a into 1 by root 2. So a will become under root 2, and the unit will become centimeter. So the answer will be root 2 into pi by root 2 and pi by 4. So the option A will be correct. Now the last question, I guess. A particle performing simple harmonic motion is found at equilibrium position at t is equals to 1 sec, and it is found to have a speed of 0.25 meter per second at t is equals to 2 second. If the period of oscillation is 8 second, calculate the amplitude of oscillations. See, this is a very long question. Okay, particle is at equilibrium position at t is equals to 1 second. So what is the general equation of displacement of particle? So y is equals to a sine omega t plus phi. At equilibrium position, at equilibrium, y is equals to 0 and t is equals to 1. So substitute the value. 0 is equals to a into sine omega plus phi. The time period of oscillation is given as 8 seconds. So omega can be written as 2 pi by t. So omega will become 2 pi by 8, or if we solve this, omega will become pi by 4. So substitute this here. So 0 is equals to a sine omega. Omega is pi by 4 into 1 plus phi. Now tell me, if the amplitude a is equals to 0, then there will be no simple harmonic motion. So if the object is executing simple harmonic motion, a cannot be 0. So sine pi by 4 plus phi is equals to 0. the value of sine theta is 0 at angle of 0 degrees. So pi by 4 plus phi is equals to 0. So we can find the value of phi is minus pi by 4. So if we substitute this in equation of displacement, so y can be written as a sine pi. Pi is pi by 4, so pi by 4 into t minus pi by 4. Now another value is given, and the value is given as the speed of 0.25 meter per second, 0.25 meter per second at t is equals to 2. So can we find the value of velocity here? So velocity v is equals to dy by dt, and this will become a into pi by 4 cos pi by 4 into t minus pi by 4. See, I have differentiated the term. The a will be constant. The differentiation of sine will become cos, and pi by t, pi by 4 into t minus pi by 4 is written as the angle. And now if we differentiate the angle inside, so the differentiation of pi by 4 into t will become pi by 4. Now substitute the value at t is equals to 2 second, v is equals to 0.25 meter per second. We can rewrite it as 1 by 4 meter per second. Now substitute the value. So the value will become 1 by 4 is equals to a into pi by 4 into cos pi by 4 multiply by 2 minus pi by 4. See, the 4 will be cancelled out here. So 1 is equals to a into pi into cos pi by 4 is multiplied by 2. So pi by 2 minus pi by 4. So this will become pi by 4. Now substitute the value. 1 is equals to a into pi into cos pi by 4. Cos 45 degree is equals to 1 by root 2. So it will be 1 by root 2, and the value of a will become, if we cross multiply this, root 2 upon pi. So this will be the amplitude, and the unit will become meter. So a is equals to root 2 upon pi meter, and root 2 upon pi is the option A. Okay, so thank you everybody. I hope you guys have enjoyed this session. Thank you. We'll see you tomorrow.